Public transport across Greater Melbourne takes up the longest travel time among all transport modes, and the further you go out of central Melbourne, the longer public transport takes. This highlights a socioeconomic inequity, as outer suburbs have a larger share of economically disadvantaged areas compared to central Melbourne. Patterns of disadvantages to accessibility like this must inform our urban planning. So as city planners, we need to understand how infrastructure changes affect accessibility and equity across neighborhoods. How can urban planners answer these questions? The answer: they'd need to see the ripple effects. But how? The answer is Flowcation. Flowcation is a visual tool that simulates the impact of changes to transport infrastructure to support urban planners in making data-informed decisions. Flowcation helps emphasize multimodal transport and public service coverage gaps, highlight the need for data-driven decision support in urban planning, expose transportation service inequities, and provide a visible way for authorities to analyze and tackle the challenge through simulation. Our goal is to visualize the gaps within a 20-minute accessibility and simulate how changes in transport infrastructure affect how far you can reach. And here's a demo of Flowcation.
So here we have the tool we developed. This is a map visualization of 20-minute travel rings, and you have configurable parameters on the sidebar here. Right now we're looking at the City of Melbourne in peak traffic with a filter for primary schools. Areas outside of these travel rings indicate shortfalls in the 20-minute neighbourhood goal. This tool is highly modular. You can add any transport method. Here is how the travel rings change when you shop to cycling and walking. You can also highlight other facilities such as cafes, doctors, and so on. Any building part of the OpenStreetMaps database is available. Here is a map with GP clinics. We also implemented Victoria traffic data. By switching from peak and off-peak, you can see how congestion negatively affects the travel rings. By adding in bike lanes, walking paths, and public transport routes, a portion of drivers will convert to the new infrastructure. We're working on adding this tool so that city planners can view the precise impact adding infrastructure will have based on measurable conversion rates. This tool facilitates viewing accessibility inequities as smaller rings, which occur in outer suburbs, and assist urban planners to focus on critical areas. Under the hood, this tool runs on OpenStreetMap graphs. We map real traffic light coordinates, link them with Victoria traffic signal IDs, and apply time delays based on measured volumes. That's what let us model realistic peak and off-peak travel times. The system is fully modular. We can swap in any facility type or transport mode, whether that's cars, bikes, walking, buses, trams, or trains. Looking ahead, the same framework can take in external datasets and machine learning forecasts like weather, roadworks, or predicted congestion, so planners can test scenarios and even anticipate demand before it happens.